technique. So today's our topic is selection short here. So in the previous example, we given that bubble and as well as linear sort mechanism. What is mean by bubble sort? Bubble sort is nothing but selecting the adjacent elements and compare adjacent two elements according to either ascending or descending order. Interchange the two values and place the minimum or maximum value into top of the array. This situation happens until we get the elements either in ascending or descending order. Similarly, the second one is given that linear sort mechanism. In linear sort, select the element and compare with all other remaining elements according to either ascending or descending order. Interchange the values and place minimum or maximum value into top of the array. This situation also happens until we get the elements either in ascending or descending order here. So, whereas in selection sort mechanism, the selection sort select the element. In selection sort, select the element and select the minimum or maximum value position according to either ascending or descending order. Interchange that values and place the minimum or maximum value into top of the array. This situation also happens until we get the elements either in ascending or descending order mechanism. Let's, for example, these are the sum of elements in our array, that is 45, 20, 30 and as well as 15 here. Now these elements we want to place in ascending order mechanism. According to the ascending order mechanism, first select the element. So that is first time the selection will be starts from 0. And from the 0 position, select the minimum value position where it is found. That is minimum value position is found that in third position. If the selected position and minimum value position which is not equivalent to, then we should able to interchange these two values here. So how we can check that one is if I nothing but selected position is not equivalent to min p, that is minimum value position according to ascending order, then what is I here 0 and min p is right now it is 3. So 0 is not equivalent to 3. Then temp equivalent to pointer a plus I, nothing but pointer a plus 0. What is pointer a plus 0? 45. Point a plus 0 equivalent to point a plus min p. What is point a plus min p? Point a plus 3. That is 15. Then point a plus min p equivalent to, what is point a plus min p? Point a plus 3 equivalent to temp. What is temp here? 45. So after we interchange this value, so this is 15 and 20, 30 and as well as 45. And the next time, this is next selection starts from one position. From the one position, find the minimum value. Where the minimum value is available from one position, again the same position called as one position. If minimum value position, selected position both are same, we don't require to be interchange these values here. Next time, that is selected position is 2 and select from the 2 position, select the minimum value position, that is same position it is available. So again we need not to interchange these values here. So next, if you are getting these three values in order, then automatically fourth element will be available in ascending order mechanism here. So if you observe this one, how many times this values has been interchanged, this logic here, that is only once this values has been interchanged to place in ascending order mechanism. Whereas in bubble and as well as linear sort mechanism, for the same values, if you observe that previous videos, it is interchanging the values, that is 5 times here. So that is to get in ascending order mechanism. So that comparatively bubble and as well as linear sort mechanism, the selection sort is more efficient and as well as faster here. Okay, so if you let's observe this one here. Now we are writing this program as include log.h. Here we are writing two functions here. One is minimum function, another one is called as selection sort function. The minimum function purpose is to be returning the minimum value position where it is available from the base address of array with selected position and as well as last position here. That is int pointer, that is nothing but base address of array, and this is starting position and this is last position here. And this is a selection sort function. This is a base address of array and number of elements in the array. So now if you observe this main function, pointer a n comma I, enter the number of elements, accept the elements, and allocating dynamic memory for number of elements. A equivalent to int pointer malloc n multiplication size of integer. If you entered n is 5, then it is going to allocating dynamic memory for 5 elements and store that address into A. Then enter the array elements. For I equivalent 0, I less than n, I plus plus. Scanf %ld a plus I. What is a here? Base address. So first time it is storing a plus 0, a plus 1, a plus 2, a plus 3, a plus 4 up to n minus 1 positions here. Then before sort, you are just printing the elements. How we are printing these elements? For I equivalent 0, I less than n, I plus plus, printf %ld slash t pointer a plus I. A plus I gives address, pointer gives value from the addresses. Then we are calling this function selection sort function. So through the selection sort, we are passing the base address and as well as number of elements here. Then what is this function purpose is placing the array elements in order, that is in ascending order. So after short, again we are printing printf percentage slash the pointer a plus I. That is for loop, that is I equivalent 0, I less than n, I plus plus. Then we close this for loop and we close the main function. Now if you observe this one here, that is void selection sort into pointer a into n. Nothing but base address of array and number of elements here. So here int I is for selections, min p is for minimum value position, and temp is for interchange the values. That is third variable. For I equivalent to 0, I less than n minus 1, I plus plus. Then we are calling this one min p equivalent to minimum of. What is minimum? Is a function. Through this function, what we are passing base address of array. That is right now we are assuming as 1000. I. What is I? Starting location. What is the first location here? 0. N. What is n here? Number of elements. Right now, what is the number of elements? That is 45. We enter these elements here. Those are elements are called as 45, 20, 30, and as well as 15. That is 4 elements here. This address is A, and starting position is I 0, and n is nothing but 4 elements here. These 3 parameters we are passing through this function here. Whenever you call this function, that is passing to the function definition. What is the function definition? If you let's observe this one, into pointer a comma s comma e, last element here. So how will you find the minimum value? That we already given in the previous example also. So assume the starting element as minimum and compare with all other remaining elements. When it compare with all other remaining elements, the rest of elements may be minimum values or may not be the minimum values here. So first we are assuming that min equivalent to pointer a plus s. What is s right now? 0. That is I value. So pointer a plus 0. What is pointer a plus 0? Min p equivalent to s. What is min p equivalent to s? Pointer a plus 0 right now. What is pointer a plus 0? According to our assumption of this values, pointer a plus 0 is 45 here. Min p equivalent to s nothing but 0. Now this is going to comparing here. How we are comparing this one here? For this is comparing like this here. For I equivalent to s plus 1. What is s right now? 0. 0 plus 1. Nothing but I equivalent to 1. I is less than e. What is e now? 4 elements. So pointer a plus I. Nothing but pointer a plus 1. What is pointer a plus 1? Is less than min. What is min value? We assumed as right now we are assumed as min value is pointer a plus is 45. 45 is less than pointer a plus 1. Nothing but 20. Condition is true. Condition true is nothing but now what is the minimum value here? Min equivalent to then pointer a plus I nothing but 20. Then min p equivalent to here it is called as I here. What is I value right now? 1. Then I plus plus. What is I plus plus? 2. Pointer a plus 2. What is pointer a plus 2? 30. 30 less than 20. Condition false. Then I plus plus. What is I plus plus? 3. Pointer a plus 3. What is pointer a plus 3? 15. 15 less than min. What is min? 20. Condition true. Then min equivalent to pointer a plus 3. That is 15. Min p equivalent to I. What is I value? 3. So now that is returning min p. What is min p right now? 3. 3 is written to the caller. What is the caller is stored into min p variable. What is min p right now? 3. Then if I, what is I value? Selected position 0. 0 not equivalent to min p. Nothing but 3. Condition true. Condition true means temp equivalent to pointer a plus I. Nothing but pointer a plus 0. 45. Pointer a plus 0 equivalent to pointer a plus min p. Nothing but pointer a plus 3 is 15. Pointer a plus 3 equivalent to temp. What is temp value is 45. So the two values has been interchanged and we got these two elements are like this here. Or we got this element here. If let's observe, this is 15 and as well as this is 45. Next time what will happen here? Then I plus plus here. What is I plus plus becomes 1. What is 1 here? Less than 3. Condition true. Again minimum of a comma I. What is a base address? I comma is 1. 1 comma 3. That is 4 elements. So again same position if it is 1. If it is fine in same position, it will not return any minimum position. That is 0. That is same position is nothing but this is 1 and this min p is also 1. Again next time it is. So next time what will happen here? I is 1 and as well as n is nothing but 4 elements. So when we call this function, it is going to returning the 1 here. So that is nothing but I is 1, selected position is 1 and minimum p is also 1. If it is both are in same position, will not enter. Next time I plus plus is 2. Minimum function again calling I is 2 and n is 4 elements. That is a minimum function is returning the same position because 30 is available in the same position. That is a minimum position, second position here. The selected position and minimum position both are same because the function what we are writing this one it is going to checking the minimum value from the starting position up to the last position here. That is starting position is I is, if it is second position from the two position, if it is third position from the third position, if it is one position from the one position, from one position compare with the rest of all elements, from two position compare with all other rest of elements. So right now it is 2. From the 2 position, if it is finding the minimum value, we are having the elements 15, 20, 30 and as well as 45. So from the second position is nothing but 30. So from the 30 position, that is second position, rest of elements if it is comparing, there is no other minimum values. So that we'll get the same position, that is 2 position. If both are not equivalent to this condition is false. Condition false means then it will not interchange these values here. So like this, once if you observe this one after completion, if this is if block is closed and I loop is closed, and as well as whatever we return that function is closed here. After we close, this is main key, that is for loop, this function, and this if condition is closed and this is for loop is closed. After close the for loop, then we close this function here. After we close this function here, then if we let's observe this one here, this is minimum function. So if you want to be getting descending order mechanism, if you want to get in descending order mechanism, you just try to replace this name of the function as maximum, and you just rename these functions as max and as well as max p, and you just try to change the condition here. What is the condition here? If point a plus a is greater than max, that is only the requirement to be changed this one here. So according to descending order, you need to find the maximum value position here, so that you will get in descending order mechanism here. So this is a selection sort mechanism here. So in the previous videos we explained that bubble and as well as linear sort mechanism. Bubble sort mechanism and linear sort mechanism is going to interchange the values, that is same for the same values what we explained, that is a 5 times interchange, but here it's getting to interchange only once here. So that is the reason what we used to say that selection sort is more efficient faster than the bubble and as well as linear sort mechanism here. So users, you maybe understand what we explained the techniques of sorting, so which are to be placing in ascending or descending order mechanism here. So users, if you like this video, please like and share, and for more updated videos please subscribe our channel. Thank you one and all.